Section 3.2. Okay, so we have to do 5 to 43 odd. So let me get that for you. Page 302. More there. Okay. And some graphs there. And I think you can see up to 43 there, which is how far we had to go. Okay, 5C, P of X is 2x squared plus 3. So we start with our basic x squared. 2x squared stretches it out more. And then 2x squared plus 3 moves the whole graph up 3 units. Okay, 5D, negative x plus 2 squared. So here's x squared. X plus 2 squared moves the graph 2 to the left. And then the minus sign reflects across the x-axis. So it ends up coming down here. 7B, negative x cubed plus 27. So the green is the basic graph of x cubed. If I reflect across the x-axis, that gives me negative x cubed, and then shove the whole graph up 27 units. So I get the red one for the final answer. Okay. Number 10, we have to see the book for that. So number 10 is graph number 1. Okay, x squared minus 4. You have zeros at -2, +2. And for n behavior, when x gets very big, either positive or negative, we go to negative infinity. So that's going to be number 1. Okay, 12 is Roman numeral 2. Okay, so n behavior, when x gets big, both x and negative x, positive and negative infinity, the y values get super big. Okay, so that's that one. Then 14 is Roman numeral 4, it looks like. Negative x cubed plus 2x squared. Zeros are at 0, 0. When x gets big, y goes to negative infinity. When x gets negative big, y goes to positive infinity. Right, so that's what we have for that one. Okay, so how do I graph a polynomial? P of x. So first get the zeros, 0, 3, and -2. 0, 3, and -2. I got -3 there, so this should be over here. Pretend this is -2. Marked it off wrong. Okay, when x gets big, y goes in negative infinity. That's negative big, positive big, positive big. So that's negative big number. X goes to infinity, y goes to negative infinity. X goes to negative infinity, y goes to infinity. Negative 1,000,000, that's positive, negative, negative. So it ends up going like that. Then what you do is pick a number in between each of the 0 sections. So f of 1, put a 1, negative, see, negative, negative, positive. So that's positive, so it goes up. Plug in -1, negative, -1 is a positive, negative, positive, so it's negative, so it goes down. So the entire graph looks something like that, except this should be -2, not -3. That's the idea. Okay, P of x is x plus 2, x plus 1, x minus 2, x minus 3. The zeros are -2, -1, 2, and 3. Check n behavior when x is super big, like 1,000,000, positive, 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 like that. If x is a big negative, negative 1,000,000, negative, 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 so positive. Okay, and then f, or you could pick something to the left here like -3. Okay, in between here, -1.5, positive, negative, negative, negative. That leaves me with a negative, so it goes down. F of 0, positive, positive, negative, negative, so the whole thing is positive, goes up. 2.5 is between 2 and 3. 2.5, positive, 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 negative, so the whole thing is negative, goes down. And then f of 4, or I plugged in 1,000,000, that would also work. Positive, 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 they're all positive. So the graph looks something like that. Okay, 29 The zeros are 0, -2, and 3. Okay, on this side, -3, that's negative, negative. Well, this is always positive. So plus, 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 no matter what I plug in for here, it'll be positive, right? Except for 3. So negative times positive is positive, positive on this side. Plug in -1, negative, positive. We already know that's positive, so the whole thing is negative, goes down. Plug in 2. Plug in 1. Let's see. Plug in 1, positive, positive, positive. Should be positive. Looks like I messed up here. Positive, which means the graph should go like this. Correct myself there. And then f of 4, positive, 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 all positive, so it goes like that. Okay, 35. X to the 4th minus 3x cubed plus 2x squared. Factor more, x squared, x minus 1, x minus 2. So the zeros are 0, 1, and 2. Just focus here. Okay, if I plug in a negative large number, negative, negative, positive, so positive. Okay, plug in 0.5, 0.5, negative, positive, positive, so the whole thing is negative. Get this thing focused here. 1.5, positive, negative, positive, so it goes down. And plug in 10, positive, 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 positive. Okay. That's what we have for that one. 37, factor by grouping, x squared times x minus 1 minus parentheses x plus 1, x plus 1, x squared minus 1, x plus 1 times another x plus 1 squared, x minus 1. So the zeros are -1 and 1. Okay, plug in -2, positive, negative, negative. Plug in 0, positive, negative, negative. Plug in 2, positive, positive, positive. So the graph looks something like that. 41, factor out by grouping, x cubed, x minus 2, minus 8, x minus 2. Factor some more, x cubed minus 8 times x minus 2. This factors out as x minus 2 times another x minus 2, x squared plus 2x plus 4. Okay. This expression can be shown to always be positive. If you factor like so, x squared plus 2x plus 1, x plus 1 squared plus 3, this is always positive. So the only 0 is at x equals 2. But if you stop and think about it, if this is always positive, that's always positive. So the graph automatically goes something like that. Okay, 43. X to the 4th minus 3x squared minus 4 can be factored as x squared minus 4, x squared plus 1. This is always positive. So x plus 2, x minus 2, x squared plus 1. The zeros are -2 and 2. Plug in -3. This thing's always positive, so plus, plus, plus. -3 here becomes negative, negative, positive, so positive. Plug in 0, positive, negative, positive. The whole thing is negative, goes down. Plug in 3, positive, 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 positive. So graph looks something like that. All right, so that was section 3.2.